Hi everyone, Scientist Fabio here.
And I'm Scientist Miller, here from NASA to inform you about our technological advancements at the International Space Station.
A big problem here at NASA is how astronauts need to obtain a well-rounded, nutritious diet while on long missions.
Everyone needs safe, fresh, healthy food from day to day. We are trying to make sure astronauts get the nutrients they need and try to grow plants at microgravity.
Our space technology focus is called the Advanced Plant Experiments, also known as APEX. That is on the ISS.
APEX is also controlled and experimented with the Veggie Production System, or VEGGIE as it's called, that helps grow and guide what we will be explaining shortly.
The APEX that is on the ISS is continuing investigations and experiment into the effects of microgravity of the development of root and cells on plant seedlings. This first used the model plant, a weed called Arabidopsis thaliana, actually naturally grown in Africa. They are now successfully using lettuce seeds and cabbage, also now starting to grow pea pods.
The Vegetable Production System experiments run 7 to 12 days and can harvest after another 6 days, so each plant takes about 2 weeks. The plants sit in what's called pillows that has control release timed fertilizer and a type of calcined clay used on baseball fields. This clay increases airflow because of the microgravity in space.
Red and green LED lights are shining above them to produce the sunlight and nutrients plants would need to grow. Each pillow also receives 100 milliliters of water. The veggie utilizes the cabin environment for temperature control and has sources of carbon dioxide to promote growth.
Our fellow colleague at NASA, Dr. Gioja Massa, said, "The farther and longer humans go away from Earth, the greater the need to be able to grow plants for food, atmosphere recycling, and psychological benefits."
We want people to benefit from our APEX growing, gaining knowledge from this research to translate into a deeper mechanistic understanding of molecule pathways that govern root growth and cell weight development, This will benefit agriculture practices and bioenergy research on Earth, beyond, and space.
Understanding these pathways to grow plants in microgravity will help guide genetic engineering of plants to support long-term space missions and planetary exploration. We want to be able to live at Mars, and to do so you need to naturally grow resources. Being able to grow in space is steps closer to being able to achieve these goals.
Missions can take up to 6 months, and on average, we need 2,000 calories a day. APEX plants grow fresh, organic, healthy diets to keep astronauts on and not have them eating packaged up food for the duration of their time.
With all technology, there's things that always need perfecting. Since plants really do need gravity and carbon dioxide to grow and produce, with growing in space, will the plants always be up to standards?
Scientists analyze whether plants can properly grow with lower levels of gravity. Natural sunlight is a big aspect of plant growth, but researchers must find a way to mimic sunlight on the ISS.
Our biggest concerns and limitations are using energy efficiently because resources are limited.
Energy cannot be wasted on light bulbs that help growth.
And extra heat is something you must eliminate in a spacecraft, so you cannot create different levels of heat.
In conclusion, I think this is important and worth an investment because it could lead to future production of planting on other planets. Plant systems will become important compounds of any long-duration exploration scenario.
We should even consider next different bugs to pollinate plants and eat parasites, or even try growing fruit.
We need to start thinking beyond what needs to happen at Earth.
That starts with growing beyond our Earth.
Thank you for joining us today. I'm Scientist Fabio.
And I'm Scientist Miller, blasting off.